This video is going to be looking at 6.3 Newton's third law of motion. We won't be talking about momentum. That'll be in a second part to this chapter. But it's good to think about what you might have known about it while you're watching this video. You only have one learning goal for tonight, and that is to describe action-reaction force pairs. The other two are going to be part of the second video, which you'll watch in another night. Newton's third law, which is known as the action-reaction law, a nickname, comes into play anytime two objects are interacting with one another. And specifically anytime two objects are going to touch one another. So in the example that you can see, the basketball player is about to shoot the ball. The force that he's putting on the ball is the action, and there is a reaction that he feels as a recoil. Newton's third law written out says that every action force creates a reaction force that's equal in strength and opposite in direction. And you can't ever have a single force alone. You're always going to have some pair acting with it. So in that last example, which would be what the top part of that picture is, the basketball player throws the ball, and the reaction is he feels the ball push back on his hand. In a similar situation, if someone were to catch a ball, the action would be the ball applying force onto the hand, and the reaction is the ball would feel a little bit of a recoil back in itself. Technically, it doesn't matter which one you call the action and reaction. It just matters that you understand that it's two objects interacting with each other. It's not one object having a bunch of different forces on it and then canceling out the opposite ones. So this is not the same as Newton's first law, which is dealing with one object and how all of the forces together either are balanced or unbalanced. What will help you understand identifying these action and reaction forces is drawing diagrams out, not as detailed as the skateboarding person to the left, but definitely some free body diagrams of two bodies interacting, because it will help you identify your action and reaction forces. So once you have it laid out that way, answering or filling in the blanks of a question like that below can be simpler. So go ahead and try that. This data table should sum up everything about action and reaction. Definitely take this down, very important. So the guidelines that have to occur, both are always there whenever any force appears. So they're always going to have forces. They will always have the exact same strength, so equal strength. They're always going to act in the opposite direction, equal and opposite. They're always going to act on different objects. This isn't about one object. It's about two objects that touch and interact. And both are small typically, not always, but they can cause change in motion. I'm going to leave you with this image. It's describing Newton's third law in relation to momentum. I'm not going to go in depth into what it means yet, but I want you to kind of look at it and take it in and try to get an idea of how Newton's third law, action-reaction, might be related to mass and speed or velocity and acceleration. With that, I'm going to end the video. Have a good night and see you in class.